Welcome, Wildcats. Today we are going to be looking at the next section of our Algebra 2. That would be section 5.3. But I figured we'd take a brief walk through the woods as we do it to relax and meditate on the fact that so far in Unit 5 we have really done no math. Unfortunately, that changes a little bit starting today, but let me walk you guys through it. It's really not too bad. 5.3, solving quadratic equations by taking square roots. So, let's go ahead and hop right into it. We're going to show you several different methods of doing this. The first one is going to be solving it by graphing. So, there's one pro to this. It's easy. All you got to do is graph it. You can do this on a calculator or you can do it with Desmos, also a pro. Very nice. And also nice, no math required. Perfect. That's what you guys like to hear. Unfortunately, you can only get approximate answers, not exact answers. Obviously, if it crosses at, if the solution is 2 or -2, you can get those. Those can be exact answers. But if the answer is the square root of 2 or negative square root of 2, the graphing can't get you that. It can get you the approximation, but it can't get you the exact number. So that's one big downside. If the problem asks you for an exact answer, graphing can't get you that. The second con, which for you guys may not be that serious, is that it actually requires you to have a calculator or Desmos with you to use. So let's take a look at what we're actually going to do when we solve these by graphing. It's very, very similar to the things that we've done in the past. So first of all, you're going to graph the left side of the equation. Then you're going to graph the right side of the equation. Usually that's going to look like y equals and then whatever numbers on the right side of the equation. You're going to figure out where those two graphs intersect. There should be 2 spots. And then you dunsies. 3 simple steps in order to figure out what the answer is. So let's take a look at an example. In this case, we're going to want to solve x squared minus 1 equals 3, but we're going to do it by graphing. So first thing you need to do is go to Desmos. So when you're at Desmos, you're going to pop into the graphing calculator. So first graph the left side of the equation. That's x squared minus 1. Okay, that is graphed. Next, graph the right side of the equation. Y equals 3. Also done. Next, figure out where they intersect. Here and here. So I have 2 solutions, which you may not be able to see. If I zoom in, can you see? No. If I make this bigger, can we see? How about now? Yeah, that should be better. So, -2 and 2. X equals -2, x equals 2. Those are our 2 solutions graphically for this problem. So, if that's one way to do it, what are the others? Well, let's go ahead and take a look at the next one. Solving by factoring. Now, factoring, as you guys know, is not too bad. It does have a couple of pros. It's not too hard. You can do it without a calculator, so that's nice. You don't have to have that specialty tool. Unfortunately, it actually requires you to do math. And you also have to actually know how to factor, something that some of you guys have not been super comfortable with. Finally, the biggest downside about trying to solve these by factoring is that it only works when there's a rational answer. So if your answer is 1/2 or 3, it works just fine. But if your answer is the square root of 7, it's not going to work so hot. Let's take a look at the steps. It is very straightforward. First of all, get your equation equal to 0. Factor the equation and identify your solutions. It's that straightforward. So, for example, we're going to use the same example. We have x squared minus 1 equals 3. We need to get this equal to 0. But right now we have 3 on the right. The opposite of 3 is minus 3. So if we subtract 3 from both sides, you get x minus 4, because negative 1 minus 3 is negative 4, equals 0. So x squared minus 4 equals 0. Now we just have to factor it. Well, x squared is a perfect square, 4 is a perfect square, and we have subtraction between them. So we can use our special factoring rule to factor that as x plus 2 and x minus 2. Still equals 0. Our next step is to identify our two solutions. So we would bring these down. X plus 2 equals 0. X minus 2 equals 0. If x plus 2 equals 0, then our solution is negative 2. And if x minus 2 equals 0, then x equals 2 is our solution. So you just set each of these sections equal to 0 and solve them independently. We've done that before. We've actually done that quite a bit in previous units. So hopefully that is not a new method for you. But again, it does only work when there is a rational answer like a whole number or a simple fraction. Moving on though, we do have one more method, and it's actually the title of this unit, or this section. Solving by taking square roots. So our solution method is going to be a little similar. It does have some pretty significant pros. First of all, it gives us an exact answer. So if we need to know that it is 3 times the square root of 2, this is the only method that can give that to us. It's the easiest one to do if you don't have access to a calculator, assuming you know a couple of simple square roots. If you don't know those square roots, you may have a few difficulties with it, but I can show you some tricks. This is the best method for solving quadratics, hands down. Nothing beats it. However, of course, it does have some cons. It does require more math than the other methods. It requires you to understand and how to apply PEMDAS backwards. And finally, the biggest downside is you actually can't do it on a calculator. If you try to do it on a calculator, such as with NSolve, it's going to give you approximations, and that's not what you're looking for. You're looking for those exact answers. That's the entire reason you're doing it this way. So, unfortunately, that is the same as generally true for things like photomath. Not going to give you exact answers. It'll give you the decimal approximations, but not exact answers. So, the steps, relatively straightforward. You want to get your x squared term all by itself, or isolate it. In order to do that, you're going to work through PEMDAS backwards most of the way. Your second step is to take the square root of both sides. That's that E step of PEMDAS. If you have a square root in the denominator, you need to rationalize it. Couple of reminders. When you're taking the square root of something, in order to get the correct answer, you need to put the plus minus sign at the beginning. So if you take the square root of a number, throw in that plus minus sign. So if you're taking the square root of 4, it's plus or minus 2, not just 2. Also remember, the square root of a negative number is imaginary. Specifically, the square root of negative 1 is I. That's going to be important later on. So let's take a look at an example. The same one we did before. X squared minus 1 equals 3. Now before we subtracted the 3, we got negative 4, we factored it out, and we called it a day. However, let's look at the much more simple method of solving this using a square root. Our first step is to get x squared by itself. Right now we're subtracting 1 from it. Opposite of minus 1 is plus 1, so we get x squared equals 4. Now that the x squared term is by itself, we can take the square root of both sides. Well, the square root of 4 is plus or minus 2. We're done. It's that simple. Unfortunately, as you guys know, not all of them are going to be that simple. Here's an advanced example. 3 times x squared minus 8 equals 12. 3 times x squared minus 8 equals 12. Let's go ahead and move over to the document camera. 3 x squared minus 8 equals 12. Well, PEMDAS backwards says we start with addition and subtraction. We have minus 8 here, so we're going to add 8 to both sides. That gives us 3x squared equals 20. 12 plus 8 is 20. Next, we have to take this. We're multiplying by 3 here. Opposite of multiplication is division. So we divide both sides by 3, giving us x squared equals 20 over 3. Now that the x squared is by itself, we take the square root of both sides and we get x equals plus or minus the square root of 20 over 3. However, this is not the answer that they want. They want it in simplest terms. So how do we take the square root of 20 over 3 to be the simplest terms? Well, let's start with just the numerator, the square root of 20. 20 can be rewritten as 2 times 10, and 10 can be written as 2 times 5. So 20 is 2 times 2 times 5. So the square root of 20 is the square root of 2 times 2 times 5. And we talked earlier about how to turn this. We have a pair of 2's, so one of them gets out. So square root of 2 times 2 times 5 is the same as saying 2 times the square root of 5. Now in the denominator, we just have the square root of 3. And we can't do anything with that, so we're just going to leave that. So we're going to have on the numerator 2 times the square root of 5 divided by the square root of 3. Now remember that very last step I gave you. It said to rationalize the denominator if necessary. While this is technically correct, no mathematician would ever write it this way. That's because we have a rule in math that says you can never have a square root sign in the denominator of a problem. Why? I honestly don't know. All I know is it's the rule. So because it's the rule, we follow it. However, it's a very easy thing to fix. Whatever's in the denominator that has the square root sign, we're just going to multiply by a fancy way of writing 1. This is something else we've done before. So square root of 3 times the square root of 3 on the bottom is just 3. Then we have 2 times the square root of 5 times the square root of 3. Well, 5 times 3 is 15, so we have 2 square root of 15. So the square root of 20 over 3 is 2 times the square root of 15 over 3. These are the same thing. This is the simplest form, but don't forget, when we take the square root of something, we're going to throw this plus or minus sign out front. So our final answer is plus or minus 2 times the square root of 15 over 3. As you can see, there is quite a bit of math here, but it is all simple multiplication and division. I did a little bit of addition here at the beginning. I divided. Now, square root is complicated, but notice that when I took the square root, I actually didn't have to know any squares or anything. All I had to be able to do was take 20 divided by 2 and 10 divided by 2. And then I rewrote the square root of 20 as 2 times the square root of 5. That's the hardest step here. And even that is just 2 division problems. Once I finished that, I just had to realize that I had to multiply by 1. And then I was done. So guys, even though there is a lot of steps to this, please notice that each individual step does not require a lot of effort. Each individual step is actually pretty easy. So let's go back to our slideshow. That was solving the advanced example of a square root. I have one final example for you guys because your HRW assignment, starting at I believe problem 10, asks you several questions about how to square a number that has an I in it. So we're going to take a look at what I found to be the most complex and hard of those. So the problem that they gave was negative I times square root of 2 over 2. And they wanted to know what you get if you square that. Luckily, it's a very step-by-step simple process. First thing we're going to do is we're going to take that squared and we're going to apply it to each of the three parts. So we're going to square negative I, we're going to square the square root of 2, and we're going to square 2. And that'll look like this. Well, negative I squared, a negative times a negative is a positive. So negative I times negative I is just I squared. Square root of 2 times the square root of 2 is just 2. 2 times 2 is 4. So we have I squared times 2 on top, 4 on bottom. Well, I squared, that's a definition. We defined that even earlier in this video. But the square root of negative 1 is I. So I squared is negative 1. So we have negative 1 times 2 divided by 4. Well, 2 over 4 is 1/2. And negative 1 times 1/2 is simply negative 1/2. So that big complicated looking thing at the beginning, it could just be rewritten as negative 1/2. So with that, guys, that gives you everything you need to be able to do your HRW assignment for 5.3. There is also for 5.3 going to be a CUDA worksheet. That is, for those of you who are remote learners, that's going to be in the 5.3 folder in Schoology. You'll be able to find it there. So you've got 2 assignments that are associated with this, but you have 3 in-class days to do it. Monday, Tuesday, Wednesday. Thursday and Friday this week, just like before, are going to be SAT prep. So with that, Wildcats, you should have everything you need. But as always, hit me up if you need some help.